Hey everyone, today we'll be focusing on binary search trees today. Particularly we will be focusing on inserting a node inside of a full binary search tree, and without any further hesitation, let's get started. And now we're going to be going over building out our full binary search tree. So to be able to give an overview, when we are creating a full binary search tree, the definition of such is that a full binary search tree is a type of binary search tree in which every node other than the leaves has exactly two children. Here we have a stick figure representation of such, where we have one indicated as a root, and it has two children of nodes, 2 and 3, over here. Then we have 2 having exactly two children, 4 and 5, as indicated over here. And we have node 3 with two children, 6 and 7. Now 4, 5, 6, and 7 are considered leaves over here, which means that there are no children, or they don't have two children per se. And this would be considered a full binary search tree. And it's also indicated where every non-leaf node has exactly two children. So we see this over here. And yeah, this is a full binary search tree. So in order for us to be able to build this out, first thing we're going to do, we're going to include our libraries. And we're also going to have a class. We're going to have two public instances. Public instance for helper functions. Public instance for functions we will call upon. So the libraries that we're going to be importing are going to be the following. We're going to have include iOS stream. We're going to have more 1, 2, 3, 4. Include queue. Include stack. And include our header file that we made right here. I'm going to have binary search tree header. And now we're going to have our class. I'm going to call this binary search tree over here. And now we will also have a public instance that we're going to call upon. So public for node root. We initialize. Root. Then we're going to have our helper function for inserting a node. And I'm just building out helper functions for our respective tasks. So we have 1, 2, 3, 4, 5. 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 9. So we have insert. We are going to remove a node. We're going to perform in order traversal over here. This is for the traversals. Pre-order traversal. Post-order traversal. And we're gonna perform breadth first search iteratively. We're also gonna do this recursively. I will do the same thing for depth first search as well. Yep, all right. And now we will be focusing on, and this will be the public instance for the function we're going to call upon. So I'm going to have public over here to start with. And so what we'll be doing to be able to first focusing on inserting a node is that I'm going to have node insert record. We'll have node int data. Then we're going to have to check if the node is null, create a new node. If not node, return new node with the respective data. And then otherwise we will go down the tree to insert the node recursively. People can do it either way, but we're going to go from the left to the right. That means we're going to have if the data is less than node specifically for the data that we're just trying to put it in. That means we're going to put it on the leftmost side. Notice in our tree for a following pattern as well, we have 2, 4, and 5, and then we have the other greater numbers on the right-hand side as well. So this is why we do this. Notice the tree and how less numbers are on the left, more numbers on the right. Over here, less, more. So node on the left is going to be equal to insert record for the node on the left side, and then with respective data as well. And then otherwise, if it is more than, then that means we're going to put this on the right side. We're going to insert the record for node and right with the respective data we have, and then finally we're going to return our node since we have a function. So yeah, it uses principles of recursion already to be able to actually return what we need. And now that we have already have our node already here, now what I'm going to be doing, I'm just going to keep this out so when we are running it. Now I'm going to test this function out by first actually putting our public instance over here, and then I'm going to call upon our search tree over here, and we're going to call upon our root that we made above over here as this class here, and we're going to initialize null pointer here. We're going to insert a node into the tree. That means we're going to go void insert int data, and all we got to do is do root is equal to, you guessed it, we're going to call this function that we made up here and put it all the way down here. And then we're going to put, since there are how many parameters? 1, 2, node, int, and data. That means we're going to have the root and respective data as well. Let me make sure this is all good. All right, build succeeded. That's good. Calls upon our helper function that we need. And now I'm going to put this inside of the main file. So that means what I'm going to do is that we're going to initialize first binary search tree, and put in a number. I'm going to put in 10, 5, 10, 5, 20, 3, 7, 15, 25. And that means I'm going to go tree dot insert that we have over here. Good. Then we're going to go 10. And we're going to just follow this list that we have. 1, 2, 3, 4. So we have 5, 20, 3, 7, 15, 25. And then I'm going to have our printer print out the binary search tree so we see it. So I'm going to call this BST printer as indicated by our header file that we have over here, calling upon this class. And then we're going to have printer dot print tree from our following class that we did at the following root. And then I'm going to have tree dot root that we have. There we go. Since we're calling upon the binary search tree that we have over here, and we're calling it directly at its root that we have made, and then it's going to be able to print it out. That's what we hope. So let me just build this, make sure it's all good. Build succeeded. And I'm going to pull up this terminal over here, and then we're going to run this. And voila, so we have our binary search tree already right here. And this is how we insert our following nodes inside of the binary search tree. Notice how in particular, the nodes on the left-hand side are less than the root, and the nodes on the right-hand side are greater than the root. This is how we create our full binary search tree and inserting the following nodes. Now that we have done so already, let's move over and focus on building out our helper function and focus on the next task for removing a node from a tree, our binary search tree. Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions or suggestions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.